Hey, good morning, guys. Can you able to hear me?
Yes, sir. Good morning.
Good morning. I'm sharing my screen. Can you able to see my screen?
Yes, visible.
Okay. 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 Thanks. Basically, yesterday we were talking about physical machine versus virtual machine versus containers. Okay. So, any questions on that, guys, before going further? On containers, guys? Who else is there? Utkasha is there, right? Sandesh. Junaid, you were not there yesterday. Aishwarya was joined, right?
Yes, sir.
Yeah. Okay. Anyway, she will join it again. So, any questions, guys? No
Yes.
questions?
Yeah.
Yeah. Okay. Fair enough. We'll go further. So, basically, yesterday we were talking about this comparison between the different compute services. So, physical machine basically is a physical hardware system, okay, on which we are working in. Whereas the virtual machine is a compute resource that uses software instead of physical compute to run a program and deploy application. Basically, virtual machine sits on the top of the physical machines. Okay, and then whatever resources are there, basically it's sharing the resources of that physical machines. Then comes containers, basically. Okay, containers are lightweight packages of your application code together with dependencies. Okay, so I have some features of containers. We will today we will give more concentration around the containers, Dockers, and Kubernetes. So, guys, this is very important session for you all, guys. So, so there are some features basically for the containers. Okay, so less overhead. Containers requires less system resources than the traditional or hardware virtual machines environments because they don't include operating system images. Okay, so if you see very carefully, so this is the image for containers. Okay, so it has a virtualization. Inside the virtualization, there is a Linux. Okay, that is the operating system. Somebody is coming in. Yes. Okay, and then Linux is a operating system, and inside the operating system there is a container platform or a component. And inside that component, we have containers. We don't have virtual machines. We have containers. They don't have operating systems. Whereas, unlike this, so here we have a Linux and Windows operating systems. No, but in containers we don't have operating system at all. So they have some dependencies on which the Java application is running in. Similarly, here also. So here also we have the Java application running in. Here also we have some .NET application running in basically, but they have dependency, but no operating system that is there available. Okay. The next is increase the portability because of the containers. So application running in containers can be deployed easily to multiple different operating system and hardware platform. So from one operating system, we can able to move that to the another operating system very easily. Then second is a more consistent operations. So DevOps teams knows applications in containers will run the same regardless of where they are deployed. So sometimes for application has multiple environments. For an example, they have development environment, they have testing environment, staging environment, production environment. So regardless of this environment, everywhere your components or containers will run the same. That is the advantages. And next is a greater efficiency. Containers allow application to be more rapidly deployed, patches and scaled. So this is very important, guys. Yesterday I shown you the Docker Hub, right? So in the Docker Hub, you need to upload your image and then you can pull the image anytime into your Docker, your machine containers, and then you can start running it. Better application development. Containers support agile and DevOps efforts to accelerate the development, test, and production cycles. So this is basically important as far as container goes. Next slide. So now we'll be talking about Docker. So Docker has some definitions. So basically, Docker is an open source software platform used to create, deploy, and manage virtualized application containers. Okay, it has some benefits. Quickly, we can take it that. Uh, Portability across machines. You may deploy your containerized program to any other system that runs Docker after testing it. You can be confident that it will perform precisely as it did during the test. Okay, so portability across the machine. So it is portable. You can install Docker in your machine, even the machine you are operating just now. I will show you that. So go to the browser. Okay, go to the browser and then type Docker for desktop. Okay, okay. Containerized software, containerization software for developers and teams. Okay, so you can download the Docker. Okay, so for which operating system do you guys have in your machine?
So Windows.
Windows
Windows 10,
11.
12.
11.
Yes.
Okay, okay, okay. It runs on 10 or 11 operating system, but I guess they need a enterprise edition. But you can try it on this actually. So you can download and then it will start downloading it. So desktop is downloading it basically. But you check once. But very interesting, Docker, and then Docker. This has a kind of Kubernetes also included. It is now not installed in my machine. It was there basically, but my machine got everything I reinstall again. So that's the reason it is gone. But yes, this is very interesting basically. But you should do this. Okay, and then coming back to the Docker, then it's a lightweight. As I said, uh, portability performance advantage can aid in making your development process more fluid and responsive. Okay, because there is no operating system involved in that. Only some of the libraries are involved in that. So that is how you can do it. Isolation, any supporting software your application requires is included in the Docker container that hosts one of your application. Hence, Docker containers are completely self-contained. And scalability, last, if the demand for your apps necessitates, you can quickly generate new containers. You can use variety of containers management technique when using multiple containers. Okay, so Docker is very useful. Most of the time, 90% people are 19 people are using Docker for containerization. Moving to the next, Docker versus virtual machines. Quickly, I will take that. So basically, what is a virtual machine? By definition, virtual machine is an emulation of a physical computer inside a host machine. So there is a host machine as well as a client machine. Okay, running on a top of the host operating system is a piece of software called a hypervisor. Okay, that controls the virtual machine instances. Each virtual machine instance has its own guest operating systems. You can have multiple virtual machines, each running a different application on a different operating system. So yesterday I shown you the virtual box. Okay, so this is a virtual box case. Okay, and inside the virtual machine, you have different operating systems. And then you can run your application. So that is how it is going on. So basically, virtualization is something like this. So virtualization basically is inside the host operating system, your guest operating system works in. Okay, and then Docker containers. It's a container that and it's very similar to the physical uh, containers. Okay, that you can use to store, package, and transport goods. A Docker container is a portable unit of software that has the application along with the associated dependency and configuration. Unlike a virtual machine, Docker containers do not boot up. There is small amount of boot up is required. Okay, boot up their own guest operating system. Rather, they run on a top of the host operating system. This is facilitated by a container engine. So there is a container engine basically. Okay. So boots in a few seconds. Boot time is very small in the Docker, whereas for the virtual machine, it's huge. Why? Because virtual machine has their operating system included. Okay. So Docker runs on a Docker engine, whereas virtual machine runs on a hypervisor. So this is a hypervisor basically. So memory efficiency, very small footprint is required as far as memory goes. Uh, Entire operating system runs on a memory. So that's the reason your memory, huge memory is required always. Isolation, prone to adversities as no provision for isolated systems. For isolated system, interference possibility is minimum because the efficient isolation mechanism. Of course, isolation is there for both the systems where your application is running in. Deployment is easy as far as Docker goes. A single image containerized can be used across all the platform. Deployment is comparatively lengthy as separate instances are responsible for execution. Okay. And usage, Docker has a complex usage mechanism consisting both third-party and Docker managed tools, whereas the virtual machine tools are easy to use and simpler to work with. Okay, so this is the comparison. Next, this is the architecture. Quickly, we'll take it that. So there is some components basically in the architecture which we'll be talking very quickly. So there is a three component, very simple, three component. One is a Docker client, another is a Docker host, and third one is a Docker hub. Okay, Docker hub we did talk, and I shown you that. Maybe I can show it now also. You can type it here. So Docker hub. So this is a Docker hub where you are keeping your images, basically, and you can download it from this to your local machine by using pull request. Suppose Nginx. So Nginx. So you can download this. Okay, click on this, and then this is a command basically you need to work on. I don't have Docker at this point of time, but yes, you can do this. Docker pull in Nginx, and Nginx will come to your machine, a laptop, and then it will be containerized, and you can start running the Nginx. Okay, suppose what else? I don't know whether Tomcat. Let me check Tomcat. Nginx very similar to, yes, Tomcat also there. So all the softwares are there. So pull and then Tomcat start using it. You guys work on some of the web servers, guys? Have you done web applications anytime?
No, sir.
Web application development you are done, guys? Kamlesh, Aishwarya.
A small one, not bigger one. Like
Which, okay.
just make the page and host it.
Yeah,
Just
correct. But have you worked on any of the programming language?
yeah, Java.
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 Okay. Java works on what? Java. For running Java, what web server is required? Most of the time, Tomcat, right?
Yeah.
Yes.
No. How you are running your Java application? Tomcat, using Tomcat, right? Correct. So you need to have a Tomcat installed on your machine, right? So that is what we are doing here. So here, so your Tomcat is there, okay, as a part of images, and then you pull the image and start installing or deploying the container in your machine with this command, basically, okay, and then you can work on this. So if you go to the PPT again. So this is a client. This is your machine, guys, and where you are instructing Docker host to work on. So Docker pull, Docker build, Docker run, Docker start. This is the command you need to work on. So you need to instruct this, and then Docker host will respond to that. Okay. Docker host basically is overall it's a client server application, right? So this is not a thin client application like internet browser based. No, it is not like that. It's a thick client application, and it is a client server application. So Docker host, basically Docker host has, it's a server basically. Okay, it maintain containers, it maintain images. Okay, and then this is a Docker hub. Docker hub already I showed you. Correct. So this is a Docker client. That means it will sit on your machine, laptop, and this will, when you instruct Docker pull, it will go to the Docker host. If not, it will take it the help from Docker hub to get that image. So that way it will appear. So what is there in the as a part of the architecture? So Docker client, basically, this is this part, enables users to interact with the Docker. The Docker client will reside on the same host as the daemon. Daemon, that means this Docker daemon, or connect to a daemon on a remote host. Or sometimes it is this part is into your machine or somewhere else also. The main purpose of the Docker client is to provide a means to direct the pull of images from the registry and to have it run on Docker host. Okay, so Docker client is asking for an image. Okay, if Docker host they don't have it, they will take it from the Docker hub. That way. Okay, then comes the Docker host. Docker host basically is a complete environment to execute and run applications. So Docker host had three components. One, images. This is image basically. Images, different images and store it inside. Are the read-only binary templates used to build containers. Okay, from images you can be able to build the containers. Then second part is the containers. Containers are basically a file system, a snapshot or startup commands. They are encapsulated environment in which you run the application. This is the environment basically where you are running your application. So images, from images you're taking the image and then you creating containers out of that. Then third part is the storage. Storage is not shown here, but there is some storage available where you are storing your data. You can store data within the very writable layers of containers, but it requires a storage driver. Okay, so basically it's a data volumes. Second, third part is the Docker hub or Docker registry, we can say, are the services that provide location from where you can store and download the images. So this is how it works in. Okay, so this particular part we'll see in the practical when it comes in, but at this point of time, this is the theory we have. Okay, next we'll go to the Kubernetes. But before that, just wanted to ask, do you guys have any questions? Any questions, guys?
No, sir.
No. Okay. 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 Then comes the Kubernetes. So basically, Docker is developed by Docker, and where Kubernetes is developed by Google. So Kubernetes has a Docker included. Okay, they have the Docker included, and above and all, they have some orchestration tool available, which you can able to do it like you can able to manage the Kubernetes with the Docker in like scaling or maybe healing, that kind of activity you can do it with the Kubernetes. Okay. Kubernetes designed by Google and currently maintained by the Cloud Native Foundation as an open source containers orchestration system. So when you install a Docker desktop, that time Kubernetes as well will get included. So there is a one tab basically through which you can able to understand that Kubernetes running or not. If not run, you need to tick, there is a checkbox. Okay, so you need to click the checkbox and then it will install Kubernetes component into it. And then you can start running it. That is what you need to do it, guys. Then it helps in automating application deployment, scaling, and management. It has some features. So service discovery and load balancing. So basically, you can able to load balance the application between Kubernetes. So Kubernetes can expose containers using the DNS names and using their own IP addresses. If traffic to container is high, Kubernetes is able to load balance and distribute the network traffic so the deployment is stable. Okay, so different containers or Docker images, containers basically, not the images, containers, you can load balance basically. And when the traffic comes, it distributes the traffic across the containers. That is what we can do. Then storage orchestration. Kubernetes allow you to automatically mount a storage system of your choice, such as local storage, public cloud providers, and more. Okay, that is what we can do it. Then automated rollouts and rollbacks. You can describe the desired state of your deployed containers using Kubernetes, and it can change the actual state to the desired state at a controlled rate. For an example, you can automate Kubernetes to create a new containers for your deployment, remove existing containers, and adopt all the resources to the new containers. That is what you can do it. Then self-healing. Self-healing basically Kubernetes restart containers that fails. Suppose some containers are failing because of some issue. Replacing the containers, kill the containers that don't respond to your user-defined health check and doesn't advertise them to clients until they are ready to serve. Okay. Then the secret and configuration management. That means it keeps the sensitive information secretly. So that is the next part. And then horizontal scaling. Horizontal scaling, scaling your application up and down with simple command with a UI or automatically based on CPU usage. That is what it can do it. Horizontal scaling and designed for accessibility. Add features to your Kubernetes cluster without changing upstream source code. That is what Kubernetes do. Slightly difficult to understand because until unless you are not doing the practical, you'll not get the feel how it is working. But still, this is a theory, and then we'll go ahead and then in the practical, we'll come again back to this definition and all. Then Kubernetes components. So what are the Kubernetes components? So Kubernetes components are two kind of components. One is a hardware, another is a software. Okay. So Kubernetes, there is a node basically. Okay. On the node, you have pod deployed, and inside the pod, you have similar containers. You can see here. Similar containers you can deploy it on the pod basically. Okay. Similarly, we have another pod. We have one more pod. We can have so many pod basically. So this is basically a worker node. Okay. So in the node, basically you have, this is a virtual machine. Okay. In Kubernetes, where either a virtual or physical machine. So this is deployed on your either a virtual machine or a physical machine. So this is a node basically. Okay. When the multiple nodes coming together, that time we call them as a cluster. So cluster is a set of nodes that runs containerized applications. Okay. So this is hardware, guys. And then we have volumes where you are keeping the data. Okay. So this is a hardware component. Then comes the software component. Software component is a pod. First is a pod basically. Pod is a group of containers deployed together on the same host. Okay. So pod is deployed on a same host or maybe node. Okay. So it is on a node, multiple pods we can deploy it there. And inside the pod, we have similar containers available, similar kind of containers. Okay, one container or more than one container. That is what we have. Containers are self-contained environments where applications are executed. Okay, so in this containers, we have some environments or maybe some code, source code, where these applications are executed. Ingress basically is a routing rules or maybe traffic that decides how the external services access the services. So somebody wants to access this application that is reside in the container. So how they are going to access it, that is ingress basically. Okay, going to the next slide quickly. This is the architecture again. This is a Kubernetes architecture. We have seen the Docker architecture. So this is a control plane. This part is the control plane. This is a node 1. This is a node 2. And then we can have node 3, node 4, whatever it may be. Okay. So in a master node, we have API servers. Okay. So API servers handle all the requests and enable communication across the stack services. It or handle all the requests. So you guys here working on this node. You guys are working on this node. This is again a client server application. Okay. So in the client server, this is a node where you are going to deploy the pods and then containers. Okay. And in the containers, there will be a container runtime. Okay. And then they are going to run your application. So API server is basically, this is API server. This is a Kube API server, and they are going to run the, they are going to handle the request and enable the communication. Then etcd servers, basically etcd servers basically is a key value store, data store basically for keeping your information. So etcd store. Then scheduler is this. Scheduler is a control plane process which assign pods to the node. So basically is a process where it is assigning where the pods will be deployed. So that is what scheduler is going to decide on. And then controller manager manages set of the controllers. So different set of the controllers to manage the Kubernetes. So maybe multiple controllers are there. So maybe you can think about node controller. Node controller is for checking the cloud provider to determine if the node has been deleted in the cloud after the stop responding. Then second controller is a root controller for setting up routes in the underlying cloud infrastructure. And then third one will be the service controller. And more controllers are there, but this is the three important controllers for creating, updating, and deleting cloud providers load balancer. So these are some of the controllers. Then coming to the worker node. Now you'll be talking with control plane using kubelet. Okay. Kubelet basically an agent which runs on each node in the cluster. Okay. So this is an agent basically through which you can talk with the control plane. Then kube proxy. Kube proxy basically the network proxy. You can think about this is a kind of network that is available. And then third one is a container runtime. Container engine runs containers on a host operating systems basically. Okay, so this looks slightly complex for you guys. Leave it as is it. Think of this. This will take through the practical again, and then we'll come back again on this slide again. Till the time, if you have any questions, I am ready to take that question. Docker and Kubernetes.
No, sir. I think it will.
This is a slightly complex. I understand that. But anything quickly that I can answer you.
Okay.
Anything? Kamlesh?
Sir, Kubernetes architecture.
I can't hear you.
So Kubernetes architecture.
Yes, Kubernetes architecture. Tell me.
Node 1 वो फिर से बता सकते हैं?
Your voice is very low. Can you talk a bit loud, please?
Sir, node 1 part.
Yeah, node 1 part. Okay. Tell me.
से बदलते हैं नहीं समझ
Your voice is again low. What is your question, Kamlesh?
He's asking to repeat it again. This node one. How
Acha,
it,
completely node 1 you are talking?
yeah.
So node 1 basically is a worker node. Okay. I'll show it to you. Okay. So there are the two nodes available. One is a master node. This is a master node, and this is a worker node. So this is the same replica of node 1 again. Okay. So multiple nodes we have. 1, 2, 3, 4, 5, 6, 7, 8, that way. Okay. I will explain you in a better way. Let us take me a step back and then tell you. So, guys, this is the client server technology. Okay. This is a master node. Okay. Then we have a worker node. This is a worker node. Okay. Worker node 1. And this is a worker node 2. Okay. Very similar. Okay. So what happens here is this talk to this, and also this talk to this. So you can think of that. There will be multiple worker node. Okay. And you can think about one more, maybe. One more. That is not the issue. Okay. So it will talk to this as well. Okay. Now, what is there in a node? Okay. We'll step by step we'll take. So there is a, one second. Okay. So there is a pod. Okay. So this is the pod. Okay. Okay. And then
These nodes are similar to VMs or
no. Okay. I'll tell you. Okay. So okay. So this is your virtual machine. This is your virtual machine. One second. This is your virtual machine. Okay. Inside the virtual machine, there is a, I will save it this one second. Okay. Now inside the virtual machine, there is a different components. Okay. There is a master node. Okay. Then there is a worker node, and there may be a multiple worker node, maybe one or more than that, right? Then in the worker node, we'll start with the worker node first. In the worker node, there is a pod. Okay. And inside the pod, there is a containers. So one container or more than one container. Ideally, it should be one container, but yes, you can have more than that. So this is a container. This is a container. Or I can say it's C2. Okay, so this is what you should be having as a pod. Then you can have multiple such pods available. Okay, so multiple pods you should be having. So this is a pod one, this is a pod two, and inside the pod, what is the containers? And then containers has a some dependency and some applications. Okay, good. Now there is one more component that is there. Is this is a container runtime. Through which your container is running. Otherwise, there is no scope that it will run it. Okay, this is a container runtime. Based on that, your containers are running. Then there is a kubelet. Now I will design the kubelet. Kubelet basically is a it's a small executables, or it's a small interactive uh, some component. Okay, I'll tell you what is that. This is a kubelet. Kubelet. Okay. Now I need to talk to master with this. Okay, because this is what we have in our machine. Okay, what I'll do, I slightly change this. And I'll put this kubelet here. Okay, so this is your worker node 1. Similarly, we have the worker node 2 and similar kind of component. Now, kubelet will talk with somebody. What is that? So kubelet is a component. It will talk with somebody of master node. That is the API manager. Okay. Then we have some more components in the Kubernetes, that is etcd. Okay, I will not take this icon. Maybe some other icon I can take it. One second. Okay, I will take this one. So basically, it's a database. etcd is a database. etcd is a database. Okay. Now this is more appropriate. Okay. Then comes the scheduler. Scheduler. Okay. Scheduler again, similar kind. Scheduler basically think that where this pod will deployed on a nodes. So that is a job of scheduler. Okay. So there is an interaction between API and then this one. Both are talking. Okay. And then there is one more component that is as a controller manager. Controller manager. Okay. So controller manager, multiple controller managers are there. Out of that, one is node controller manager to take care of node. Then there is a root controller manager. Then there is one more is there, service controller manager. Okay, and then this kubelet basically is a cube cutter. Okay, so I can't show you it right now, but go to the Kubernetes. Okay, command for creating content or pod, maybe we can think of pod or something. Okay, so when you have this command, that time kubectl basically. So this command, kubectl is a command, is a kubelet command. Okay, so that is a kubelet, kubectl, through which you are interacting with the master. Okay, through the API manager, scheduler, and then data will be resides on a etcd, and then controller manager for controlling all these activities. So similar kind of will be there in, so I'm deleting this, just repeating this. So this is your worker node 2. Okay. So this is how it is going to happen. There will be more than one worker node, 1, 2, 3, 4, 5, so many are basically. Okay. So any specific questions, guys, on this? Or this is fine? You're going to see the practical of it, but this is a theory session at this point of time. So we'll go ahead with the theory and then we'll have a practical.
Okay, sir.
Completion, this is fine, right?
Okay.
Yeah. So what I'll do, I will paste this into your chat, this architecture. Okay. Coming back to the PPT. Okay. So this is what we thought of. So think of that. This is a client server architecture. Server this is a master node is a server, whereas you have different clients, worker node basically, one or more than that. So that is what this architecture is slightly complex, but this may be simple for you guys, right? This may be simple for you. Okay, I will post this in a chat. Coming back to the next part. So this is a Docker and Kubernetes. So Docker and Kubernetes is huge topic and very interesting topic for you guys. Maybe you need to learn a lot on this because it's themselves, they are a different world altogether. If you go to the YouTube, there is a different session that is available on the Kubernetes. So just type the Kubernetes. Okay, maybe you can type fundamentals or something. So many things are there. So explains 6 minutes or something. So they will Kubernetes. Okay, so maybe this is a refresh for you all guys again. Maybe so. This is some of them. Coming back to the session. So we are done with the Docker, we are done with the Kubernetes. Now the things comes up. And then just to tell you that all the three CSPs, Azure, AWS, and GCP, all the different CSPs has Kubernetes implementation. Okay. So for them, this is a Kubernetes implementation. Okay, this is what we can have it quickly. For AWS, there is the EKS. Okay, for Azure, there is the AKS. And for GCP, there is a GKS. Okay, so this is Elastic Kubernetes services. So for Kubernetes, there is a terminology called as a K8S. Why? Because I'll tell you what is that. And then Azure K8S services. Google. So basically, why we are denoting Kubernetes as a K8S? Because Kubernetes. Okay, so this is a word basically. Between K and S, there is 8 characters. So K and S, there is 8 characters. 1, 2, 3, 4, 5, 6, 7, 8 characters. These are the 8 characters basically. That's the reason 8. Okay, so all the 3 CSPs have this Kubernetes implementation. So coming back to the CSP market share. Now, this is what. Okay. And anybody heard about Gartner? Guys, yes or no? You need to tell me quickly.
No, sir.
No. Why others are not responding? Why, Junaid, you are not now answering? Who answered now? Aishwarya, is it? Where is the Utkarsha? Sudesh? Sandesh? Guys, I want this session to be interactive session. Tell me, yes or no? Have you heard about Gartner?
No.
Yes, no. Sandesh?
No, sir. No, I don't have
No.
it.
Okay. Okay, no worries. Utkarsha, you did talk? Or Aishwarya?
No, sir. I don't have idea.
Okay. Okay. Basically, Gartner is a company who into the understanding about the market shares and then different research papers they're publishing in. Okay. And they have their values basically. Okay. So if you go to the gartner.com, where you can get to know like which trend is very popular. For an example, top 10 secure software development tools, maybe. Okay. So that is what they are into. So, and their reports are very useful reports, basically. And whatever market trend, whatever market trend they are publishing in, basically, they are having a lot of meaning. They have a lot of research papers and a lot of documentation they are providing in the not only for cloud but all the software areas. Okay, so they have published every year. They are publishing Magic Quadrant on different areas, and one of the area is a cloud infrastructure. Okay, and in that infrastructure Magic Quadrant, there is a four areas. One is the challenges, another is the leaders, second is the visionals, and then fourth one is like niche players. Okay, aspirant basically. So that is what they are. So from this area they are going to this area, or from this area they are going to this area. Sometimes they have some challenges, they will go to this area as well. But if you see that carefully, Amazon Web Service is top of everyone. Okay, so as far as Amazon Web Services goes, they are the top, and they have a lot of market shares, which I will explain that. Second is Microsoft. Third one is Google. Apart from that, in the visionaries, we have Alibaba Cloud, and then we have Oracle, and then IBM is somewhere in the niche players and all. Okay, I can move this quick. Prison Cloud, and then Huawei Cloud. I don't know if they have something. Oracle is in visionaries. Okay, so yes, so Gartner has published that there are three leaders, and Amazon Web Services is top among them. AWS as a total, they have 34% market share, whereas the Azure has a 21% of the market share. Then Google Cloud has 11% of the market share. With this, AWS is leading in the cloud service provider market. Coming to the next slide. Uh, Before that, I have one more slide which I will talk on. This is very interesting, maybe. Yes, this slide I will talk. So basically, you have Amazon Web Services, you have Azure, and then you have Google Cloud Platform. Okay, so as far as market share concerns, as I said, 34% is Amazon Web Services, 21% is Microsoft Azure, and then 11% is Google Platform, and then rest everyone. Okay, so maybe you can look into the internet and then find out rest who are they. That is what you can do. Coming back to the CSP again. So I guess we have very little time for this particular slide. Okay, we'll start this slide from the next session maybe, because this is an important slide, and then we can talk a lot on this slide. So just wanted to check you if you guys have some questions or something, so I can take that maybe. So Docker related or Kubernetes related. Can you guys install Docker for desktop in your machine? today, and let me know the feedback tomorrow.
This Docker desktop one or Docker Hub?
No. Docker Hub basically is a registry.
Okay.
Okay. So Docker for desktop. That is what you need to install it. Docker for desktop. This is what you need to work on basically. Install this in your machine. As I said, prerequisite for Docker. Okay. So prerequisites, there is some requirement basically. Let me take you through the requirement. 64-bit processor. Nowadays, everyone has that 64-bit, so that is not the issue. Only the operating system is the issue. So this is some of the tools that Docker for desktop expect you to install on. But I guess when you start installing, everything will come a bundle in the Docker desktop. Just check that. Only I'm worried about the operating system. Docker desktop installation exe. You just install it. So this icon will come in, and through which you can work in. Or maybe tomorrow sometimes I will get it installed and then I will show you how you can work on this. Maybe that is also I can do. But just wondering the Windows operating system. Windows. Yes, this is very important, guys. So operating system Windows 10, home, professional, or enterprise. Just check because I understood that enterprise is required most of the time. Just check once what operating system you have and whether that is compatible or not. So this is very important. Okay. So this I will post it. Okay, I will post this maybe in chat. I'll post this into the chat. Then you need to start basically. Okay, we'll check maybe tomorrow. I will get it installed maybe tomorrow very quickly, and then I can able to show you that. Okay. So guys, any questions? Anything you want to ask me?
No, sir.
No, sir.
No? Okay, then we can stop here and then we'll meet again tomorrow. So tomorrow what we'll do, you try to install Docker for desktop maybe tomorrow in your machine. Similarly, I will do that in my machine. May not be this machine, but somewhere, maybe virtual machine or somewhere I will do that. And then maybe I can create a step-by-step guide, and over the chat, I will upload it. Okay. So then you can verify that with the installation you are done in your machine. Okay, so that may be the test for you guys, maybe homework for you guys. We'll meet again tomorrow. Okay.
Yes, sir.
Yeah, thanks a lot. Bye. Take care.
Thank you, sir.